Hello, this is Mrs. Taylor, and I'm going to introduce you to the mean value theorem. This particular definition is from the Finney, Demena, and Waite's calculus textbook. And it states that if y equals f of x is continuous at every point on the closed interval a to b, and differentiable at every point of its interior, the open interval a to b, then there is at least one point C in a B at which f prime of C equals f of B minus f of A over B minus A. So this is very notation heavy, but a couple things to note. The condition is that it's continuous on the closed interval and differentiable on the open interval. So if you're asked the mean value theorem applies, you have to prove that those two things are true. And then if they are, then you're guaranteed some C value, which is basically saying some X value in the open interval where your derivative at that X value, so that's your instantaneous rate of change, your slope of your tangent line, it means all of those things. So there's some X value guaranteed that when you take the derivative and evaluate it at this X value, it's going to equal the average rate of change, which is also known as the slope of the secant line. So visually, this is a little easier to understand. If you think of the tangent line and the secant line, you think through this. At this point right here at C, the tangent line is horizontal because I have a relative maximum. Actually, this is the absolute maximum. And so my derivative would be equal to 0, which would make a horizontal tangent line. And then if I look at these 2 points here at my endpoints, the secant line, the line that connects those 2 points, is horizontal as well, roughly. This is hand-drawn, but it is supposed to be horizontal. And so if both of these lines are horizontal, then their slopes would be the same, so they would be parallel. So really what this theorem is saying is if you have some closed interval and your curve is smooth, no cusps, corners, any place where it's not differentiable, you're guaranteed that at some point a tangent line, any tangent line, will be parallel to a secant line. And this is used most often to prove that you have a horizontal tangent line somewhere. But really the two main pieces you need to remember is the conditions, so it has to be continuous and differentiable. Continuous on the closed interval, differentiable on the open interval. It's a really important distinction. And then also that this is your general formula for completing the work. So you take the derivative, set it equal to the average rate of change, and then solve for your C value, your X value. So let's look at an example, and again this example is also from the Finney, Demena, and Waite calculus textbook. And in the example it says, show that the function f of x equals x squared satisfies the hypotheses of the mean value theorem on the interval 0 to 2, then find a solution C to the equation f prime of C equals f of B minus f of A all over B minus A. So, in order to show that the function satisfies the hypotheses, I have to show that it is continuous on the closed interval and differentiable on the open interval. And so, because it is a monomial, we know those are continuous. It's just a parabola. We also know that it's a smooth curve. So, basically all I'd have to do is state that it's continuous and differentiable. So I could write f of x is a polynomial, therefore f of x is continuous on the closed interval 0 to 2 and differentiable on the open interval 0 to 2. So the mean value theorem applies. And a lot of times you'll see the mean value theorem abbreviated as just MVT. And you're welcome to use that abbreviation. It is understood that that's what that means. So on your exams and tests you can use just MVT. So now that we've established that the theorem applies, then I need to actually find the solution. So first thing I need is f prime, and f prime of x is 2x, so it's pretty straightforward. And then I need to evaluate f of b minus f of a over b minus a. And b and a are just the endpoints of your interval. So when I plug those in, it would look like this: f of 2 minus f of 0 over 2 minus 0. And note that this is f, so I'd plug 2 into 2 squared and 0 into 0 squared. And then once I do that, this would become 4 minus 0 over 2 minus 0, which would reduce to 2. So I have my f prime, I have my difference quotient, that's what this is called. And just so that you're relating these to the other concepts, this is the instantaneous rate of change, this is the average rate of change, this is the slope of the tangent line, this is the slope of the secant line. So it means many different things. But what I'm looking for is the c value where these two are equivalent. So I would set 2x equal to 2, and then I would solve, so x would equal 1. However, when I provide my final answer, they've asked you to find a solution for c. And so your final answer needs to be c equals whatever the value is. And the reason why that's so important is because sometimes you'll solve these equations and you'll get more than one solution. However, not all of them will be on the interval that they've specified. So you need to reference the interval and make sure that you only provide the solutions that are actually in that interval. And so my two answers would be explaining why the mean value theorem applies, and then also solving for c. So just to kind of bring everything together, you've learned a lot of value theorems, and so I just wanted to give you a one-stop look at how they're all related. So you've learned the IVT, the intermediate value theorem. The requirement or condition is that f is continuous on a closed interval. And basically this guarantees a y value. So it's saying, okay, if you have a continuous function on a closed interval, you're guaranteed that a certain y value exists. If your y value falls between the y values at the endpoints. And then the extreme value theorem is same condition, f has to be continuous on a closed interval, but this guarantees an extreme value. So this guarantees that you'll either have a maximum or a minimum. And that's the one we did yesterday, where if it's a closed interval and it's continuous, you're guaranteed to have absolute max and absolute minimum. And then the MVT is what you just learned, and that states that if f is continuous on a closed interval and differentiable on an open interval, so this is the first one that has two conditions. If those two things are true, then it guarantees a tangent line parallel to a secant line. It guarantees a certain derivative value equal to the average rate of change. So there's a little summary of the different value theorems you've learned so far, and I look forward to practicing this with you in class.